Hi, it's Rob. Welcome to the next video in the Infrastructure as Code on AWS with Terraform playlist, where we'll look at securing secrets using HashiCorp Vault. HashiCorp Vault is an identity-based secrets and encryption management system, which provides gated encryption services which are accessed via Vault's UI, CLI, or HTTP API. Vault controls access to secrets and encryption keys by authenticating users and applications against trusted identity sources such as Active Directory, LDAP, and Cloud Platform Identity Management Services. Vault has a variety of services, but it is most commonly used for identity-based access management, data encryption, both in transit and at rest, and management of secrets such as API keys, database credentials, environment variables, and other sensitive data. But before we start working with Vault, let's take a quick look at secret management in Terraform, starting with the AWS provider block configuration. To get started, looking at the AWS IAM console, we see I have two users, a cloud user who belongs to a developers group which has administrator access, and the cloud user currently has one set of access keys. The other user's name is Terraform Developer. It also belongs to the devs group, but currently has no access keys. Looking at my current system's AWS configuration, we'll see that I don't yet have a profile set. There are no entries in my AWS config or in my AWS credentials. Looking at this demo code, we see I have three Terraform files: a main TF, which specifies a required provider of AWS, a provider for AWS, which sets a region, and a resource block for an EC2 instance. If I do a Terraform init and pull down the AWS provider, then do a Terraform plan, we see that I get an error indicating that Terraform couldn't find a configuration for the AWS provider. Going back to the HashiCorp AWS provider, we see that the default configuration inside of the provider is to add properties for the access key and secret access key. However, there's a warning indicating that it's not recommended to hardcode your credentials due to a risk of leakage if you commit your code to a public version control system like GitHub. But let's jump back into VS Code and add these properties to our AWS provider. First, I'll grab my cloud user's access key and secret access key, which I'll be revoking after this video, so don't worry about leakage here. Save the file and do a Terraform plan. And now we see that we're able to execute the plan with one resource to add. Now, obviously, this didn't give us an error because we provided the access key and secret access key inside of the AWS provider block. However, as previously mentioned, this isn't best practice. So for now, we'll just comment those out and look at adding them using a variable. So first, I'll create a new variables.tf file and paste in the variable blocks for the access key and secret access key. Then I'll add a terraform.tf vars file with my access key and secret access key and run a Terraform plan again, which is successful because we're referencing the values in the TF vars file for the variables that are being used to set the access key and secret access key. But again, this isn't secure because if we commit this code to GitHub, obviously our secrets are in plain text. So let's comment these out. And this time we'll add a new file for local variables. Once again, I'll add my access key and secret access key, then jump back over to the providers block, and now set the values using the local variables. And if we do a Terraform plan once again, of course this will be successful because it's just picking up the value from the locals.tf file, which again, obviously isn't secure because the credentials are hard-coded. Now, if you've been following along in the prior videos in this playlist, this probably isn't surprising to you. And you'll recall that we've never set the access key and secret access key in our providers block. What we've done is to use AWS configure to set the values for the access key and secret access key, so that when we run a Terraform plan, we're still successful because we're authenticating with AWS using the access key and secret access key in our local AWS config. So I'm going to jump into the providers block and delete this code, as well as delete the locals, the TFVARs, and variables files. Then we'll just test once again, and we're still successful. So clearly, for our local configuration, it's best practice to use the AWS configure CLI to add our access key and secret access key versus hard coding them in a source code file that could leak the credentials if it's committed to a public repo. Now, this configuration is working just fine for my IAM user named cloud_user, whose credentials are configured on my machine as the default configuration. But as I'm sure you're aware, we oftentimes aren't just working with one IAM user or profile. As we saw previously, I have 2 IAM users in this account. So let's jump into the terminal and configure a local profile for my Terraform developer IAM user. So back in the terminal, I'll execute the AWS IAM list users command to get a list of users and copy the username for the TF developer. Now I'll go ahead and execute an AWS IAM list access keys for the user cloud user, and we see that cloud user has an access key. However, if we run the same command for the Terraform developer IAM user, we see that this user currently doesn't have an access key. So now I'll execute an AWS IAM create access key command for my Terraform developer user. Now I'll go ahead and copy the access key and secret access key so I could use them to create a local profile. And as always, I'll be revoking these credentials after I create this video. And finally, I'll go ahead and execute an AWS configure, creating a named profile for my Terraform developer IAM user. And now if we do an AWS configure list, we see the credentials for the default profile. And if we do an AWS configure list, passing the profile for the Terraform developer, we see that this IAM user is now configured on my local machine as well. Now, what I'm going to do is remove the default profile from my AWS config and AWS credentials. And now we see that the only profile I have configured on my local machine is for my Terraform developer. So now if I run a Terraform apply, we see I get the error message that there's no Terraform AWS provider credentials configured. So what I'm going to do now is execute the Terraform apply with the new Terraform developer profile. And the way I do that is to jump into my AWS providers block and add a profile property equal to Terraform developer. Now I'll save the file and jump back into the terminal. And now if I run a Terraform apply, we see that I'll be able to successfully execute this plan because it's picking up the profile credentials that we configured for my Terraform user. And the apply is complete with one resource added. So that was a quick demo on how to securely use your AWS credentials on your local machine in Terraform, as well as how to use multiple AWS profiles. Now, let's move on and take a look at securing secrets such as database username and password. Now, for this demo, I've created an outputs.tf file, and inside two outputs, one for the DB username and one for the DB password. And we see the values are displayed in plain text. Now, jumping into the terminal, if I execute a Terraform plan, we'll see that the values for the DB username and password are also displayed in plain text. However, if I jump into the output block for the DB password and set the sensitive property to true, then do the Terraform plan again, this time, although the value for the DB username is displayed in plain text, the value for the DB password is hidden, and it indicates that it's a sensitive value. However, let's go ahead and execute a Terraform apply. Now the apply is complete, and again we see the DB username, but the DB password is sensitive. However, if we take a look at the terraform.tf state file, we see that in addition to the database username being displayed in plain text, the database password is also displayed in plain text, even though we set the sensitive property to true. And that's because if you watch the prior videos, you'll recall that sensitive values are always stored in the terraform.tf state file in plain text. So this is the reason why we include the TF state file in a git ignore so that we don't accidentally commit this file to a public repository. And when we use a remote backend like S3, we enable encryption to secure the state file. Okay, now that we have an understanding on how to securely use our AWS credentials and we've had an overview of the Terraform sensitive property, it's time to move on and see where HashiCorp Vault fits into the picture. Now, to get started with Vault, I'm going to go ahead and download it and install it on my local machine. Now, I'm using a Mac with Homebrew installed, so I'll copy the tab command, jump into a terminal, and execute it. Then I'll jump back over to the browser, copy the brew install command, and execute that as well. Then I'll execute a Vault version command just to ensure the installation was successful. And that looks good. Now, with Vault successfully installed, we can go ahead and start the Vault server on our local machine in development mode. So if we jump into a terminal and execute vault server-help, we'll see that running Vault server in development mode allows us to work with Vault in a development mode on our local machine. But in this configuration, Vault runs in memory. So when we stop the dev server, we'll lose whatever information, such as secrets, that we've stored in Vault. Now, this is fine for us in a learning environment, but obviously you wouldn't want to do this in production. Now, to launch the server in dev mode, I'll go ahead and execute a vault server-dev. And now our Vault server is up and running. Now, this runs in a background process, so I can't close this tab. So as we interact with Vault, I'll just leave this up and running in the background. And here we see that we can access Vault via the UI at our local host, or 127.0.0.1, port 8200. So let me jump into a browser, and I'll load that page, and now we're prompted to sign into Vault using a token. So if we go back to the terminal, here we see we're given a root token. So I'll go ahead and copy the token, jump back into the browser, paste it in, and now we're authenticated into Vault, and we see the two default secret engines. Now, in addition to working with Vault in the UI, we could also access Vault via the CLI commands. So I'll go ahead and open a new terminal and execute a vault status. And here we see we have an error message indicating that we're trying to access our Vault server using HTTPS. But remember, the address that Vault gave us to the UI is running on HTTP. So in order to fix this, we need to set an environment variable named vault_address equal to our 127.0.0.1 port 8200 running on HTTP. Now, to set the environment variable on a Mac or Linux system, we use export. In Windows, you can set this using your environment variables configuration. So I'll go ahead and execute the command. Now, if we do a vault status, we see that our command is successful. Okay, with the Vault server running in dev mode on our local machine, and we're able to interact with it using the UI and the CLI, it's time to move on and create our first secrets. To get started, I'll click on the secrets engine, which uses key value secret storage. And currently, we have no secrets created. So I'll go ahead and click Create Secret. And first, I need to enter a path. So I'll give this secret a path of db-username-secret. The key will be db_username, and the value will be dbadmin. So I'll go ahead and add the secret. Now for the second secret, I'll jump back into the terminal and use the vault kv put command to add a secret at the path secret/db-password-secret and set its key equal to db_password with a value of password123. Now, if we go back to the UI and click on the path to secret, we see we have our two secrets, db_username secret and the new db_password secret, with a key of db_password and a value of password123. So now that our secrets are created, we could go ahead and use them in Terraform. So back in VS Code, in the main TF file, inside of the required providers block in my Terraform block, I've added a required provider of Vault whose source is HashiCorp Vault with a version of 1.12.3 because this is the version that was installed using Homebrew. And in the providers.tf file, I've added a provider of Vault setting its address property equal to 127.0.0.1 on port 8200. Then I created a data.tf file and added data blocks for Vault generic secret types. The first one with a name of vault_db_username, whose path is to secret/db-username-secret. Because if we go back to the Vault UI, here we see the path is secret db-username-secret. And of course, we'll need another for db-password-secret, which I've added here. Then finally, in the outputs, I've added two output blocks, one for the Vault db-username secret, whose value is equal to going to the data block for the Vault generic secret named vault_db_username and grabbing the data JSON property. And then I did something similar for the db password using the Vault db password data block. Now I'll save the file, jump into the terminal, and before we could run this, we need to execute a Terraform init to pick up the new Vault provider. Then I'll execute a Terraform plan. And we see we get two errors referencing sensitive values from the Vault provider. So I'll jump back into the code and add the sensitive equals true properties to the new output blocks and then run Terraform plan again. And here we see that the output values for the Vault DB password and Vault DB username are sensitive values. However, if we run a Terraform apply, even though the Vault DB username and password are displayed as sensitive values in the output, if we look at the terraform.tf state file and search for Vault, we see that the Vault DB password secret and Vault DB username secret are still displayed in plain text. Because again, the terraform.ts state file always displays values in plain text. But the benefit to using Vault is that now, instead of hard coding our values for our secrets in our code, we can reference them using the Vault provider. Of course, currently, the values for our secrets are presented as key value pairs in JSON format. But what we're really interested in are the values for the keys. So let's jump back into our outputs. And instead of referencing the data_JSON property, we'll reference the data property passing in the key. Now I'll save the file, run a Terraform apply again, and jump into the state file. And now we see the value for the DB username secret is just dbadmin, and the value for the password is password123. So now that we've seen how to create secrets using the secret key value secret storage, which creates secrets as static key value pairs, I'd like to move on and show you one more very popular aspect of Vault, which is dynamic secrets. And dynamic secrets are secrets that are generated when requested. So there's no static values for anyone to potentially gain access to. And a popular use of Vault dynamic secrets is to generate temporary credentials for AWS. Now, to get started creating temporary credentials in AWS using Vault, first we'll have to enable the AWS Secrets Engine. And we can do that by clicking the Enable New Engine button, selecting AWS, then clicking Next. Here we need to enter a path for the AWS Secrets Engine, and I'll just take the default of AWS and then enable the engine. Now I need to create a role, which I can do by clicking the Create Role button. I'll give the role a name of dev role. I'll leave the default credential type as IAM user, and now I need to specify a policy document. And what I'd like to do is add a policy for EC2 full access. So I'll jump into the AWS IAM console, click on policies, search for EC2, and then open the Amazon EC2 full access policy. From here, I'll click on the JSON tab, select the statement, copy it, then go back to Vault and paste it in. And finally, create the role. Now, each time someone requests a new dev role in Vault, an IAM user will be created in AWS with an access key and secret access key with the EC2 full access policy attached. Now, for Vault to be able to create a new IAM user, we need to configure Vault with proper AWS credentials. So, back in the AWS IAM console, I'll go to Users, add a user. I'll give this user a name of Vault admin, and add the user to the devs group, which has administrator access. Now I'll go into the Vault admin user, click security credentials, and generate an access key. I'll select CLI and create the key. Then I'll copy the access key and the secret access key, then jump back over to Vault. And then in the AWS Secrets Engine, I'll click Configuration, then Configure, paste in the access key and the secret access key, and then save. Now, I'll go ahead and click on the dev role and click Generate to create an IAM user with temporary credentials. And if we look in the IAM console and go to Users, we see we now have a new user which was added by Vault. So what I want to do now is use the access key and secret access key which are generated to create a new local AWS profile, which I could then use as the credentials for the Terraform AWS provider. So I'll go ahead and copy this access key and jump to the terminal. and create a new profile named tfdev. I'll paste the access key and the secret access key. And now I have my new tfdev profile. So let's jump back into VS Code, and in the AWS providers block, I'll change the profile from tfdeveloper to tfdev, save, then open a terminal and run Terraform apply. And we see this configuration looks good, but let's go ahead and add an ec2.tf file and ensure that we can spin up an EC2 instance using this new temporary IAM user's credentials. So I'll go ahead and create a new file, add the code and save, then run a Terraform apply. And with our apply complete and one resource added, if we jump into the AWS EC2 console and go into running instances, we see our new EC2 instance named web server, which was created from our Terraform configuration using our dynamically generated AWS credential secret. So that concludes this video on integrating HashiCorp Vault with Terraform. In the next video, we'll look at Terraform Cloud. If you'd like to be notified when I add that video to the playlist, please consider subscribing to the channel. And if you found this video informative, feel free to give it a thumbs up. Thanks for watching, and I hope to see you in future videos in this Infrastructure as Code on AWS with Terraform playlist.